As we keep talking about function notation, this is the time for the interpretation of function notation. And I think this is one of the most important parts of it because we are actually connecting it with a context, with real life situations. So I hope you get to understand this pretty well, guys. So we are going to think about this context, this situation. We're going to imagine that we are probably in a kind of fall season where the outside temperature is going to change starting at 6 a.m. This is what it is telling us. So the outside temperature, F, that temperature after T hours after 6 a.m. And this is a very important part of the context to understand. We need to explain the meaning of each statement. I want you to understand certain things. So for our context, T is the input and it is also the independent variable. This is one thing, all right? We also take into account that the outside temperature, which by the way is represented in Fahrenheit degrees, is our dependent variable. And of course, it's the output. In this case, this outside temperature depends on the time after 6 a.m. All right? Now, let's understand another thing. When time equals 0, what time is it? Remember, we begin at 6 a.m. So when t equals 0, it is 6 a.m. What happens when t is 1? It means after 1 hour. It means that it's 7 in the morning and so on. Okay? Well, now let's begin with our first exercise here, which is A. And I'm going to rewrite it here. The function f, remember in this case the temperature, with an input of 0. When the input is 0, the output is 58. Remember, we did it before. Actually, let's write it that way. Okay. When the input is 0, the output is 58. Well, I know that the input is time in hours after 6 a.m. Since it is 0, what time is it in here? Well, 6 a.m. So we can say when t equals 0 is actually at 6 a.m., the output is 58. What does that mean? The output, what is the output? The output is the outside temperature. The outside temperature is 58 Fahrenheit degrees. So if we can say this just in words, please take a look at the expression again. F of 0 equals 58. F of 0 equals 58 in context is actually this. Input is 0, output is 58. But it's still very mathematical. Now we can express this whole thing in words like this. The outside temperature is 58 at 6 a.m. Or you can do it the other way around. At 6 a.m., the outside temperature is 58 Fahrenheit degrees. That's how you understand this. Make sense? Okay? Now, with that in mind, now it's easy for us to do the other ones. In this case, f of 6 equals n, it's actually that. What is this 6? The input is 6. It means 6 hours after 6 a.m. So at 12 and 12 p.m. You can say at 12 or at noon actually. Let me just rephrase this. So at noon, the outside temperature is N. We don't know it. It's just a certain value. That's it. Now, that's all. That's all I can say. Now, how about C? C is very important. Let me just erase this whole thing to make sense of all this. Okay. So in C, we get back to our inequality symbols, right? Well, but let me tell you, this is going to be really simple once you understand how those symbols work. That's going to be excellent. So let's take a look at that C. So here we go. C, they tell me f of 3 is less than f of 9. But what is this? F of 3 is the outside temperature at what time? What is 3 in this case? 3 hours after 6 a.m. It means at 9 a.m. is, all right, is, and I hope that you are remembering everything that you've learned before in terms of the less than and the notions of what those less than, greater than mean, right? Okay, so in this case, let's keep going. Less than the outside temperature at, this is 9 hours after 6 a.m. So it means 15 hours. So 15 hours is 3 p.m. So the output of f when t equals 3 is less than the output of f when t equals 9. So the temperature at 9 a.m. is less than the temperature at 3 p.m. And here we go.